Hello, students. Miss Harper,
Hey, Mr. Carmen.
back with you with another video over proportions. Proportions was a big part of your sixth grade curriculum, so hopefully you remember those. If not, we have the definition posted up here for you, which a proportion is an equation that says one ratio is equal to another. So you have two ratios or two fractions that are equal to one another. They are the same in, I went blank.
Okay, that's okay. Just think of it like this. An example that comes to my mind right away is talking about currency, like money. So the thing is that you could have a $1 bill, and then you have several variations of change that could be equivalent to a dollar, right, Miss Harper?
Right.
So, for instance, think of like a dollar. So, how many quarters is equivalent to a dollar?
4.
Exactly. So you have a ratio of $1 to 4 quarters.
Exactly.
Yeah. Just a very very light example.
Right.
Okay, so we have some examples. If you look on the right side of your screen, we do have a couple examples we will work with you all, and then we're going to give you a choice of 3 other problems you can choose from to demonstrate your thinking.
Exactly. So starting with example 1. Sheldon and Leonard are partners in a business. Sheldon makes $2 in profits for every $5 that Leonard makes. If Leonard makes $20 profit on the first item they sell, how much profit does Sheldon make?
Okay, so what I'm doing is that while Ms. Harper reads that, I'm jotting down important information. Now, of course, I apologize. My camera here in front of me is going to go in and out. So if it does that, I'll fix that as quickly as possible, okay? So Sheldon makes $2 for every time that Leonard makes $5, right, Ms. Harper?
Yes.
Okay, so my goal here is to figure out, okay, so let's say Leonard, he makes $20. I have to figure out how much money Sheldon makes. So here's what we do for a ratio. We have to keep things consistent, just like we talked about in the definition. So in the problem, if I look back over that, it says that second sentence there says Sheldon makes $2 in profits for every $5 that Leonard makes. So since they mentioned Sheldon first, I'm going to put him first in my ratio. So we're going to write this as Sheldon, and we're comparing him to Leonard. Okay, so now I'm going to go through and write the numbers that apply to the person. So Sheldon makes $2 in profit, so we're going to keep that consistent right here with Sheldon.
And I think another word for the consistency is corresponding as well.
Exactly. So
Yes.
That's another way of saying that. So consistent with corresponding. So the $2 corresponds with Sheldon, and then the $5 will correspond with Leonard. Exactly. So again, that's what info they gave us. But here's the real question. Based on this, now we have to determine, okay, let's say Leonard makes $20 in profit. Now we have to figure out how much Sheldon makes. Right. So here's the thing. Even though they mentioned $20 first, right away my brain wants to put $20 up here.
Well, you can't do that, Mr. Carmen.
Why not, Ms. Harper?
Well, it says Leonard makes $20. Exactly. Don't give Leonard's money to Sheldon. He wouldn't like that.
All right, so what was that fancy word again you talked about that correlates with that?
They have to correspond.
Correspond. So now I'm going to put the $20 and it's going to correspond with Leonard. So now my goal here is to figure out what this is. Now, before in 6th grade, you may have seen like an empty box here or a question mark. Middle school, we changed that up. We like to represent that through a variable, which we typically use the letter X most of the time. Now, sometimes that could be Y or A or B, but we're going to use X for today. So here's how we're going to do this. The first way we're going to show you is through a method that both me and Ms. Harper prefer. It's called cross multiply and divide. So what I'm going to do is that I'm going to cross multiply the numbers. Yeah, so we're going to go through and multiply the numbers that are diagonal of each other. And of course, you may have known this before maybe as the butterfly method, because from a standpoint, it looks like a butterfly. So we have 2 times 20, which will equal 40. So I'm going to write that out long ways first. So we have 2 times 20. And we're going to set that equal to 5 times x. Now, also in middle school, instead of writing the x as a multiplication symbol, we use parentheses, or we might see the dot, okay? So we're going to use parentheses for today. So we have 2 times 20, which is 40, is equal to 5 times x, which we just write that as 5x. It's just 5 directly right beside the x, okay? And then from here, we just simplify the rest of the problem, try to determine, okay, so if we have 5 times something, it's going to equal 40. So here we're going to use what's called inverse operations. So if this is being multiplied right here, we're going to do the opposite, which is what, Ms. Harper?
The opposite of multiplying would be dividing.
Exactly. So we're going to go through and divide both sides by what's called the coefficient. So 5 represents how many groups of x there is.
And what we do to one side, we have to do to the other.
Exactly. So we have divide by 5, 40 divided by 5, which equals 8. So then x, what does that represent again?
X represents Sheldon.
Exactly. So x represents the profit for Sheldon Haas. So again, always remember, anytime that you have a word problem, me and Ms. Harper expect a word answer, some kind of formal statement behind it. So the easiest way to do that is go back over the question and just restate it. So the question says, if Leonard makes $20 in profit for the fire item they sell, how much profit does Sheldon make? Just simply say Sheldon makes $8 in profit. Simple as that. Oh, let me scroll down my screen. Sorry, I couldn't see all that. There we go. Okay.
Exactly.
All right. So now we're going to go through and do example 2. So Ms. Harper, do you want to read that while I get my stuff ready here?
Yes. So looking at example 2, Allie runs 3 miles in 36 minutes for his daily workout. At this rate, how far could he run in 60 minutes? Now, keeping up with it, you have 3 miles in 36 minutes. That would be your first ratio. Then you have to determine your second ratio.
All right, you're going to give them a go, Ms. Harper.
All right. So on our second ratio, we're not given any miles, but we are given 60 minutes. Now, Mr. Carmen went on and wrote it down in the denominator. Why do you think he did that? Why did you do that?
Just like we talked about in the previous problem, since they are talking about 60 minutes, we have to make sure that corresponds with the appropriate units. So since we established that minutes come second before the miles in the word problem, we have to put that consistently together as a ratio.
Exactly. So no matter what, your units should always be in the same spot.
Okay, and always, if you're trying to figure out what the variable is in the situation or the unknown, I'll always go back to the question. They're asking about how far could he run in 60 minutes. So you don't know the distance. So in this case, you're trying to figure out the miles. So you're trying to figure out X number of, I'm sorry, I put minutes right there, put miles. There we go. All right.
Exactly.
So we're going to go back to the same exact method. We're not going to change up anything. All that's different here is just different numbers. It's still the same procedure. So we're going to go through and use cross multiplication and division. Now this one's going to be quicker just because we're doing the exact same method. So I want you to go through and cross multiply the numbers that you know. But this time I'm going to write it as a ratio, okay? So we have 3 times 60. And then based on the last step we did earlier, we know we're going to divide this answer. So the answer to a multiplication problem is a product. So we're going to divide this product by 36, which equals X. All right, so now we're going to go through and simplify that. So 3 times 60, order of operations, 3 times 60 is 180, divided by 36. Now, the thing is that I know those are high numbers. You're not going to know that right away unless you have a calculator in front of you. So if you do not have a calculator in this situation, the easiest way to do is to break this down with common factors. And honestly, what you can do right here to keep things simple, I would just go through and look for exactly what they have in common. So right away, this ends in a 0, this ends in a 6. Right away, your brain should be going to, hey, they're both even numbers, which means they're automatically divided by what?
2.
Exactly. So just take half of each one of those. So 180 divided by 2 is 90. And then half of 36 is 18.
Keep in mind, you always have to do what you do to the top, you do to the bottom, or vice versa.
Yeah, so I'm going to write my step up here. So you divide by 2, divide by 2. And here's the thing. Are they both still even?
Yes.
Let's keep going. Divide by 2 again. So divide them both by 2. Half of 90 is 45. Then half of 18 is 9. Okay. Now, go ahead, Ms. Harper.
Well, Mr. Carmen, now they're not even anymore.
No, okay. So here's the problem now. Now they're not even. So now what I would do from here is kind of just look at the next set of numbers that they might have in common. Because the thing is that where this is not simple yet, they more than likely they still have something in common. So here's what you could do. Just make a separate list out here of 45 and 9. And we're going to write down the multiples of those until I'm sorry, not multiples, but the common factors that they have in order to see what they have in common. So automatically, they both have 1. But the thing is that if we divide those by 1, are those going to change, Miss Harper?
No, they are
No.
not.
So we have to keep going. So the next factor of 9 will be 3 because you got 1 and 9, and then 3 and 3, right?
Yes, because
Okay.
3 times 3 is 9.
Yeah, and then you got 145, and then will 3 go into 45?
Yes.
Yes, because 2 doesn't go to it, so 3 times 15.
Yes.
Okay. All right, and then you got 4 and 5 as well, right? Yeah, 4 times 5. Oh wait, no, not 4 times 5. 5 times 9.
5 times 9.
Yes.
We're gonna cut that one up.
We're gonna keep that one. All right, so then we have 5 times 9.
Yes, we have 5 times 9.
Okay. So we have 1, 3, 5, 9, 15, 45. Okay, so out of these, we can see the greatest common factor is 9, but if you don't know that right away, we could always use 3, right, Miss Harper?
Yes.
Okay. So the thing is that we're going to sit with the simple ones. Let's go with 3. So we're going to divide each of those by 3. 45 divided by 3 is 15. 9 divided by 3 is 3. And then any more
15.
common factors?
Well, I
Oh, go
know
ahead.
from my experience, I know that 15 divided by 3 is 5.
Yeah. So then we just have 5. So I'm going to put my answer, since I'm running low on room, I'm going to put it right here, which is just 5, or 5 over 1. Oh, I'm sorry. I can't see the camera. There we go.
And then we also had a question.
Yes.
So my question was, how far could he run in 60 minutes? So Allie can run 5 miles in 60 minutes.
Yes.
All right.
All right, let's get that over. And the thing is that anytime these videos, if we do go a little bit too fast, you can always pause at different moments, okay?
Yes.
Okay. All right, Miss Harper, what's our next thing?
Well, now we have an assignment for you to do. It's your turn to do an assignment, and it's actually going to be your choice. As you can see, the directions. Choose one of the following problems to solve. Make sure to use a proportion. Take a picture of your work and submit it appropriately.
Okay.
So you're going to choose one of the 3 problems to work out. You're going to work it out on a sheet of paper, take a picture of it, and then you're going to turn it in on Google Classroom.
Mm-hmm. Okay. Ms. Harper, you have anything else to add before we end the video?
Nope.
Okay.
Good.
All right. Until next time, boys and girls. See y'all later.